On October 16, 2017, astronomers excitedly reported the first detection of electromagnetic waves, or light, from a gravitational wave source. Now, a year later, researchers are announcing the existence of a cosmic relative to that historic event. The discovery was made using data from a host of telescopes, including NASA's Chandra X-ray Observatory. The object of the new study, called GRB 150101b, was first reported as a gamma-ray burst detected by Fermi in January 2015. This detection and follow-up observations show that this new object shares remarkable similarities to the neutron star merger and gravitational wave source discovered by the Advanced Laser Interferometer Gravitational Wave Observatory and its European counterpart Virgo in 2017, known as GW 170817. The latest study concludes that these two separate objects may, in fact, be related. The researchers think both GRB 150101b and GW 170817 were most likely produced by the same type of event, the merger of two neutron stars. This is a catastrophic collision that generated a narrow jet or beam of high-energy particles. The jet produced a short, intense burst of gamma rays, a high-energy flash that can last only seconds. This was followed by an afterglow in optical light that lasted a few days, and X-ray emission that lasted much longer. Scientists think both of these events involved kilonovas, that is, powerful explosions that release large amounts of energy and can produce elements like gold, platinum, and uranium. Understanding these explosions helps astronomers trace our cosmic ancestry. There is still a lot to learn about these events, but Chandra is poised to help in this new era of combined gravitational wave and electromagnetic investigations into our universe.